Our group did our project on the punching process at Mass Precision. We viewed an Amada 358 King 2 in action, which is a punch laser combo. The punching process, simply put, is punching a tool into or through sheet material to achieve desired features. The punching process is limited to materials in sheet form. Although the punch press is capable of punching a wide variety of materials, we will be focusing on sheet metal. Before the punching process, the tool path must be generated by converting the 3D model into a flat profile in order to program the punching order. It is important to program the tool path of the punching process correctly to minimize time and avoid deformities caused by clusters. After the punching process, the part is placed on a scanner and compared to the drawing to verify it is within tolerance. Typical punching machines can punch one hole every 1 to 1.5 seconds with a 33-ton capacity. Punching is capable of performing many different features such as holes, embosses, lances, and louvers in material up to 1/4 of an inch thick. A cluster of holes or features can be produced in one punch by having multiple features in one tool. Because the diameter of the tool envelope is 4.5 inches, this limits the size and quantity of features that can be punched. A typical tool can cost around $300 to make, and a punching machine turret can hold up to 72 tools. Shops have libraries containing many different geometry tools that customers can design from. One challenge is the punching process is limited to simple geometry. Generally, punching is limited to straight lines, radii, and holes, and cannot perform complex and curved geometry without sacrificing both quality and time. Punching geometry is limited by the material thickness, such that the feature diameter or width must be greater than material thickness. Some alternative processes to punching are laser cutting, water jet cutting, and drilling. Laser cutting is limited to two-dimensional features but can cut complex geometries with a kerf as small as 1/10,000th of an inch. A laser is limited to cutting one feature at a time. A laser can cut material about twice as thick and in less time as punching, but it costs more to operate the laser due to the high amount of consumables. Water jet cutting is primarily used for thicker materials that the punch cannot handle. It can cut complex geometries with a kerf as small as 20,000ths of an inch. The water jet has a much slower cutting rate than punching and uses a high rate of consumables, which makes it more costly. Drilling is another way of producing holes, but it is significantly slower and inferior quality than punching. It is restricted to one hole at a time, but is not restricted by hole size. Overall, punching is a useful process to produce holes and features at a fast rate and high capacity. It is a safe process having guards and sensors, allowing the machine to be fully automated. Although punching does have limits in the types of geometries and thickness of material, it is still able to punch through materials with little to no consumables at a low cost.